Geometry Lesson 4.7a, Coordinate Geometry of Triangles. You have several new definitions: analytic geometry, coordinate geometry, and mid-segment. We have Theorem 4.7.1, the triangle mid-segment theorem. So coordinate geometry is also known as analytic geometry, and it uses coordinates referring to the Cartesian coordinate plane. So it uses a graph. Triangles can be determined to be right triangles by using the fact that slopes of perpendicular lines are negative reciprocals of each other. We can also use the distance formula to show that a triangle is scalene, isosceles, or equilateral. Here are the three formulas that you'll use in this lesson. These are the same formulas we had in Chapter 3, your slope formula, distance formula, and midpoint formula. Probably a good idea to have these written on a piece of paper so you can use them as you're going along. Let's look at example 1. Example 1 is on page 193. You see that we have a graph with 3 points plotted and lines drawn in between them, and this makes a triangle. We're to start by finding the slope of each side of the triangle. So the slope of AB, right here, would be negative 3/4. The slope of BC will be 4/3. And the slope of AC is 1/7. If you want to see all of the math behind solving for those slopes, it is in your book. One of the things we need to note is that negative 3/4 and 4/3 are negative reciprocals. Consequently, AB is perpendicular to BC. Now, it asked us to find the length of each side of the triangle. So we do that using the distance formula, and AB is 10, BC is 10, and AC is 10 square root of 2. We can see that these side lengths are the same, so we have an isosceles triangle. And because in the last step we noted that AB was perpendicular to BC, we can now state that that's a right angle, so we have an isosceles right triangle. You can also solve for side AC once you know that this angle B is a right angle by using the P theorem. Example 2. Find the midpoints of AC and BC and label the points D and E. Let's take a look at the drawing. So this is the same triangle. We want the midpoint of these two sides, AC and BC. So to find the midpoint, we're going to use the midpoint theorem and formula, and we'll see that the measure of AC equals point D, which is at 0, 2, and that's the midpoint or halfway of AC, and the measure of BC equals point E, which is the points 4, negative 1, which is the midpoint of BC, and they've drawn a line. If you need to see the work for this, for these midpoint formulas, it's in your book. The second half of that example, we now need to find the slope and the length of the mid-segment. So the mid-segment is DE, and compare our findings from example 2 to the findings from example 1. So the slope of DE equals negative 3/4. The length of DE is the square root of 25, which is 5. Now let's compare. From example 1, the slope of AB was negative 3/4. And the length of AB was 10. So let's fill that in our drawing. So this length was 10. From example 1, the slope of DE equals the slope of AB. They were both 3/4. So what does that mean? That means that they're parallel. DE is parallel to AB. And we discovered that DE is 1/2 of AB. Because DE was 5, we can fill that in. And we've now solved what they asked us to in the problem. This, from the comparison of example 1 to example 2, we can now state the triangle mid-segment theorem. A mid-segment of a triangle is parallel to the third side of the triangle and is half the length of the third side. So, if you have DE, it will be parallel to AB, and DE will be half of AB. Let's look at example 3. We're going to use the results from example 1 and use the triangle mid-segment theorem to find the slope and length of the other two mid-segments of triangle ABC. We already found DE, but all the other sides also have a mid-segment, so we're going to solve for those. The slope of FD is equal to the slope of BC, which equals 4/3. This we've determined because of the triangle mid-segment theorem. And FD will be 1/2 of BC. We knew that already from solving that BC was 10, so that means that FD will be 5. Now let's take a look at the third side of, or the third mid-segment, and this would be FE, and the slope of FE will be equal to the slope of AC, which we discovered from example 1 was 1/7. And the length of FE will be 1/2 of AC. AC was 10 square root of 2. So FE will be 5 square root of 2. And that was fairly easy. Your homework for lesson 4.7a is numbers 1 through 12. For numbers 4 through 7, use the slope formula. Number 8 is asking you these questions. What kind of a triangle is it? And what do the slopes show you or indicate? Numbers 9 through 12, use the distance formula to find the length. For all of these problems, show your formulas for all of the problems and work them vertically to solve. If you have any difficulties, be sure to contact me. We'll be doing a little more with lesson 4.7 in the next video. Have a blessed day.